So line up your zero with, I've kind of drawn the word line. Either the black angle or the black line or the pink line, which I've drawn here.
Yes.
And then we can rotate this, so I'll rotate that and realign it.
That would be...
Does that make sense why what I've done this? So I've just turned it round so that the pink line is lined up with the zero.
Yeah. It would be 65. No, 66. The red.
And then you're very close. Have a little look again. So we're looking for about here.
Yes. Yes.
Yeah, not the pink one.
Oh, I know, because I thought we were doing the 8. And it's going to be 70.
Oh, right. Yeah, so coincidentally, this way we can either work out the angle this way, which is going to be 72, is that?
Yeah, 72 it is, yes.
Yeah, or because just from coincidence we can line it up like this and we could actually use the blue scale.
Yeah.
And measure that angle like there, which is...
It's 152 subtract.
Yeah, 150, 100 and... 100 and...
76.
108, because there's the 100, there's the 5, and it's 3 in.
Yes. Oh, yes.
Yeah, do you see that?
Yes, the blue side.
The blue side, yeah, we're looking because on this side it's lined up with the blue 0,
Yes.
whereas on the other side it's lined up with the pink.
Yes.
Is this becoming clearer, the zeros thing? Because I know that was something that was hard to grasp on Wednesday.
Yes. Yeah.
Yeah, good. I'm really pleased. Yeah, so now we've got this, we need to know the bearing. That's what we're looking for. So the bearing is what I'm now colouring in orange.
Yeah.
So what will the bearing be?
We have to so add 72 to 150. It will be 180. It will be 252. 252.
Yeah, so 72 plus 180. 252. Brilliant. And that's the bearing?
Yes.
Excellent. That's really, really good.
To find the full circle, we can do 360 subtracted by 252.
Yeah, if you subtract 360 from 252, what angle will you get?
The green one.
The green one, yeah, the 108. Brilliant. That's really, really good. Okay, and then for number 5.
108 I got here. Now number 5. So, and like we don't need the digital. So, let's remove that.
You don't technically need it this time because you know enough information to work it out.
Yes. So, as 50 degrees. 50, and this line is 180.
Yep.
It's 180. That one. So.
Yeah, that angle is definitely 180. Yeah.
And we need to find this one. So we can add 180 and 50 together and subtract it.
You don't need to find that one because you've already been given the angle that's the most important. Because remember, the bearing is the angle from north all the way around to the line.
Yes.
So it's this green one that we need to find. So we don't actually need that.
No,
Is it brown? Brown one.
Yeah, we don't need. So how do we do? Okay. So from there to the whole. So So 180, 50. Two hundred and 80, 60, 230.
Yes, 230. Brilliant.
Yeah.
Yeah, because they gave us the 50, and all we need to do is plus that 180 to get that full clockwise bearing.
Yes.
Okay. One more. Have a little go at this one. Let's give us 2.
It doesn't.
Now, this one's interesting. You can either, well, you don't need the protractor, but if you want to use it, I'll let you use it. But you don't need it because you've got enough information here
Okay.
to work out the bearing. It relates to corresponding and alternate angles, which we did on Wednesday as well.
Yes.
So have a little go, but either way, I'll let you have.
So this is 70. 070. Am I question?
Yeah, go for
You
it.
see, there's 2 more, so do we have to find out this one, the Q?
Right, yeah, so the bearing that they've given us, the bearing from Q to P, because, so this is where the wording can sometimes get a bit confusing. So it says the bearing of Q from P, which means that we start at P.
Yes.
So they've started at P and then they took the north clockwise bearing to Q.
Yes.
Well, this time we need to find the bearing from of P from Q.
Yes.
And because we've got that from, we start at Q and we take the clockwise bearing from north to P, so this green one.
Okay.
Yeah, does that make sense?
Yes. Zero. 90. So Q is 90.
Yeah, so put the protractor on, we get the bearing to there, we know is 180.
Yes.
Yeah?
Yes.
So we need to do a little bit more, so I'll just put a line there so we can remember that. So we need to do a little bit more to find the rest of the bearing.
Yes. So. Okay, so can we flip it so we can. That's 180. Hold on a minute. This is 190 over there.
Yeah, we worked it out.
I'm doing it. No.
Mine's giving us 2 for everything.
So that's 90. So if it's 90, how would this? Oh,
Okay.
I know what to do.
Yeah, you got it? Okay. Have a little go.
So we need to know how much it is from there to here.
Yeah, so
So
we
90
know
subtract
from
100.
the protractor literally tells us, because we start on 0 up here on the black 0, and if we go all the way around, where I've put the green line is 180 degrees.
Yes.
So we know that this pink bit that I'm colouring in now is 180. So what we need to take the bearing is the full green circle.
Is it going to be 90? The gap is 90.
Hang on, let me colour it a different colour. This orange gap isn't quite 90 degrees, because 90, if you remember, is a right angle, so it,
Yeah, I was talking about the gap between the 180 and 90. 180. To find out.
yeah. You mean like if we drew a line here?
Yeah.
Okay. So we could draw a line like there, but then that we would know that that was 90.
Yeah.
But that doesn't really help us because then we don't know the little bit underneath that.
Yes.
Does that make sense? So, if we use the protractor, we'll do exactly what we did the last time. We'll keep it in the same place. I'm just going to spin it round, make it a bit smaller. We can spin it round and place the point back on the middle and line the 0 up with the new green line and work out the angle like that.
Yeah. And it's going to be one. No, this. Let me show you. Let me get out the pin. And then, so from here, this line.
Yeah.
To here.
Not quite from the pink line, it's from the black line. Because that's where P is. So it's along this orange line that I'm drawing.
Oh,
Can you see that?
yes. Oh, so it's going to be coming up from the.
Yeah, so we take the bearing to the black line.
Yeah. Yeah. Okay, so 2 to 110 I put. No, 105. Yeah, 105.
Careful which scale you're looking at.
70.
So we start at the bottom on the black 0, don't we?
Yeah.
So we need to use the outside black scale.
Yeah. So 70?
70, yeah. I was going to say my green line is not quite straight, so it should be 70.
Yes.
There's another way that we could have worked that out without this protractor. Can you spot what it is?
It's 70 here as well.
Yeah, it's 70 there as well. Because north is always in the same direction no matter which point you're at. The two north lines are parallel to each other, aren't they? So we can draw little arrows on them like this. Does that make sense?
Yes.
Yeah? So if we pretend that this was if we weren't even doing a bearings question and we were doing just a normal maths question like what we have been doing,
Yes.
we could draw two extended parallel lines from the north because the two norths are parallel.
Yes.
And what kind of angle is this? The two 70s like this?
Acute? No, acute.
It is acute. What kind of relationship do the two acute angles have on this set of parallel lines?
Less than 90.
Can you remember? We did them on Wednesday. There's
Correspond.
not corresponding, that it's the other one. So corresponding is the F angle.
Yes. Oh, the Z.
Yeah, or the Z. This is a Z, isn't it? But it's lay on its side.
Yes.
So I'll just go over it with a pen. Which colour? Blue. Z angle,
Yes.
also known as alternate angle.
Yes.
So we could have worked that out that angle was going to be 70 anyway.